You know that feeling when you are standing outside your car and you're just looking right through the driver's side window, you're patting your pockets, and you're looking right at your keys, just sitting there in the ignition. Or maybe they're just resting on the driver's seat.
Oh, yeah. And you need those exact keys to open the car door. But, to get the keys, you literally have to open the car door. It's a complete physical gridlock. You
Exactly.
basically cannot move forward until that loop is somehow broken.
It is the ultimate everyday paradox. And today on the deep dive, we're taking that exact maddening scenario, that whole keys locked in the car thing, and we're looking at it inside the invisible architecture of software.
Right.
Our mission today is to explore this really fascinating real-world architectural challenge. We're drawing this from a developer log titled Notes on Haskell Programming, Part 118.
Port 118, yeah.
Yeah, it was written by a programmer named Ang, and it was published on April 24th, 2026.
And the core of this log, it revolves around a project called X2 eBook. It's basically a tool designed to convert documents into, various ebook formats.
Right.
And Ang runs into this highly specific coding problem, which is called a circular dependency, which just entirely paralyzes the whole application.
And I want to say right up front to everyone listening, you do not need to be a Haskell expert to appreciate this.
No, not at all.
You don't even really need to be a programmer. Because fundamentally, this is just a story about getting stuck in a logical trap, right? And finding a surprisingly profound way out.
Totally.
We are going to extract a universal lesson here about how we organize information, whether that's code or a business or even just our own daily workflows.
Yeah, it really serves as a masterclass in structural thinking. The systems we build dictate the problems we face.
Okay, so let's unpack this, because before we can appreciate the elegant structural solution that Ang actually discovers, we have to understand the trap itself.
Right, the trap.
So the X2 ebook project is divided into different functional areas or, modules. There's this one module called xs2ebook.converter.
Right.
And that handles the actual conversion process. In this module, it needs to use a really specific data type called export format.
Yeah, and this export format type, it handles all the different formats you might want to export your ebook into. So the log lists specific formats like PDF, TEEP, EPUB, TXT, and MD.
Okay.
It's just a simple list of the possible output formats that the system actually supports.
Right, but there is a major catch here. That export format data type, it currently lives inside a totally different module called xs2ebook.cli.
Right, the CLI.
Yeah, CLI stands for command line interface, which is the part of the program the user actually types commands into.
Meaning the converter needs to look inside the CLI just to know what a PDF or an EPU even is.
Yeah.
And, on its own, module A looking at module B, that isn't a problem. But Ang's system had this existing connection flowing in the exact opposite direction. The CLI module was already importing a function called convert to ebook from the converter module.
Oh, wow. And the trap closes.
Exactly.
The converter needs the CLI to understand the export formats, but the CLI needs the converter to actually run the convert to ebook function. A needs B, but B needs A.
It's a total lockup.
But I want to pause on something right here, because why would a developer put the list of export formats inside the CLI module in the first place? It seems so obvious now that it shouldn't be there, but when you are building a system from the ground up, what is the psychology that leads to that?
Well, honestly, it all comes down to the temptation of convenience. When a developer is writing the command line interface, they're usually, building the help menu for the user.
Okay. Yeah.
They're writing the code that says, press 1 for PDF, press 2 for EPUB. And since they need that list right there in that exact moment to build the menu, it just feels perfectly logical to define the list right where they are typing. It's just human nature to build a tool exactly where you're standing.
So it's kind of like unpacking your groceries and putting the bag of flour directly on the stove just because you know you were about to make a roux.
That's exactly it.
It makes sense locally, but it fails globally. Because eventually, the converter module comes along, it needs to know what a PDF is, and it has to reach all the way over to the stove to find the flour.
Which creates our keys in the car scenario.
Yeah.
The compiler, the tool that translates human-written code into machine instructions, it just cannot handle this loop.
Right.
A compiler basically needs to figure out a linear order of operations. It essentially asks, which of these modules should I build first?
But doesn't the computer know that the export format is just a simple list of words? Why exactly does the whole system freeze up instead of just, pulling out the list it needs?
Well, what's fascinating here is how compilers actually view these modules. A compiler doesn't just look inside a file and say, oh, hey, I only need this one tiny piece. It treats a module as a locked box. It operates on this principle called a directed acyclic graph.
Okay, that sounds intense.
Yeah, it's a highly technical way of saying a one-way street with no loops.
Got it.
So when the compiler tries to build the converter module, the instructions say, I need something from the CLI box.
So the compiler just puts the converter down, goes over to the CLI box, and tries to build that one first.
Exactly. But then the CLI instructions say, wait, I need the convert to ebook function from the converter box. So the compiler goes back to the converter, which still needs the CLI, which still needs the converter.
Oh, man.
It is an infinite loop of passing the buck. Neither side can take the first step, so the compiler just throws an error and completely quits.
That makes perfect sense. So the system isn't broken because the code is somehow wrong in what it's trying to do. I mean, converting an ebook to a PDF is a completely valid action.
Right, totally valid.
It's broken because the structural organization of the rules just makes it impossible to even begin.
Yeah, it is entirely an organizational failure. As you add more and more features to a growing project, these hidden loops, they easily form, and they bring an entire application to just a grinding halt.
So the system is totally gridlocked. How does Aang break the cycle without tearing down the entire application and just starting from scratch?
Right.
The developer log details this very tactical structural fix. Aang basically creates an entirely new neutral module named xs2ebook.types.
Yeah, Aang physically extracts that export format data type, that list of PDF, TEP, EPUB, out of the CLI module and just places it right into this brand new types module.
But I noticed in the log that Aang doesn't just move the names of the formats. The notes mention moving some properties along with it, things like deriving show, EQ, enum, bounded.
Right.
I'm looking at this and thinking, why move those specific properties? Do they just tell the system how the data is allowed to behave?
Well, they do a lot more than just dictate behavior, actually. They give the data its fundamental identity. Yeah. In Haskell, a data type on its own is just an empty shell. Those derivations are its physics. Show gives the data the ability to be printed as readable text so a human can actually see it.
Okay.
EQ gives the data the ability to check if it is equal to another piece of data. It's like recognizing self versus other.
And what about enum and bounded?
Right, so those define the boundaries of the universe the data lives in. ENA means the formats can be listed in sequential order. And bounded means there is a strict first format and a strict last format. Without those derivations, the system really doesn't know what the data is. So by moving the type and all of its derivations wholesale into xs2ebook.types, Aang is relocating the entire concept of the format.
Here's where it gets really interesting, though. Let me just push back on this fix for a second.
Sure.
When I first read this, part of me thought, does just creating a new file really fix the core architecture? Because it feels a little bit like having a really messy desk. And instead of organizing the papers, you just sweep everything into a bottom drawer and close it. The mess is still there, you just don't see it anymore.
Yeah, it sounds like you're just hiding the mess, right?
Yeah.
And honestly, a lot of junior developers actually do fall into that trap. They blindly shuffle code around just to make the compiler stop yelling at them.
Exactly.
But what actually happens here is the establishment of a strict one-way flow of dependencies.
A bedrock layer.
Precisely. In solid system architecture, you really want dependencies to point downwards toward foundational concepts. When Aang moved the formats to a types module, they created a real foundation.
Right.
The converter depends on the types. The CLI depends on the types. But the types module depends on absolutely nothing. It is totally standalone.
Which guarantees that no matter how big the project gets, the compiler will always know where the starting line is. It starts with a module that doesn't need anything else to exist.
And that is what breaks the loop. Both the converter and the CLI can safely import from xss2ebook.types without relying on each other at all.
I saw the tools Stack and Cabal mentioned in the log right after this step. I assume that's just the system officially registering this new neutral zone so everyone knows it's there.
That is a great way to look at it, yeah. Stack and Cabal are the management tools for a Haskell project. Cabal acts like a city planner's master map.
Oh, nice.
By adding this new types module to the Cabal list of exposed modules, Aang is basically putting this new neighborhood on the official map. It becomes a recognized pillar of the system structure, sitting right alongside the public-facing CLI and parser modules.
So moving the code and updating the map successfully solved the immediate technical error. The compiler stopped freezing.
Right.
But for Aang, the real value of the exercise wasn't just getting the program to run again. It was the deeper philosophical realization it triggered about separating definitions from logic.
The log highlights this so beautifully.
Hmm.
The definitions dictate what the data actually is, like a PDF and EPU. They just exist as concepts. The logic dictates how that data is handled, manipulated, and transformed. So the actual conversion process, the reading of user commands.
So what does this all actually mean? Let me try to make this concrete for you. I was thinking about this like organizing a commercial kitchen in a really busy restaurant.
Oh, I like that.
Your raw ingredients, your
Yeah.
flour, your sugar, your fresh vegetables, those are your definitions. That is what the material is. Now, the logic is the actual cooking, the chopping, the boiling, the whisking.
Yeah, and if you mix your raw ingredients on the exact same counter where you are actively cooking and plating, you just get absolute chaos.
Right. You're trying to carefully plate a really delicate dish, but there's just this 50-pound sack of flour sitting right in the middle of your cutting board.
Exactly.
That's what Aang was doing by keeping the data types inside the active CLI module. But if you keep the pantry completely separate from the stove, if you create a neutral ground for your ingredients, like the types module, everything flows.
So the chef at the stove, our converter module, walks to the pantry, grabs the ingredient, and brings it back to their station.
Yeah.
And then the sous chef working on prep, the CLI module, goes to that exact same pantry, grabs what they need, and goes back to their own station. They share the ingredients without ever tripping over each other's workspaces.
But why does tangling what things are with what things do cause so much extreme fragility as these systems scale up?
Well, this raises an important question about dependencies in any complex organization. In your kitchen analogy, if the flour is permanently attached to the stove station, no one else in the kitchen can use the flour without physically interfering with the person cooking at the stove.
Right, so if the baker wants to make bread, they literally have to navigate around a giant pot of boiling soup just to reach the flour.
Exactly. In software, when you bundle a static data type like export format inside an active behavioral module like CLI, you are essentially holding that definition hostage.
Oh, wow.
Anyone who just wants to know what a PDF is suddenly have to invite the entire CLI module into their workspace. That sounds heavy.
It is. They import all of its complex behaviors, its interfaces, its own massive web of dependencies.
You just ask for a simple ingredient, and you accidentally drag the whole stove along with it. And that brings us right back to the keys in the car.
It does. Aang's realization here is a true hallmark of mature system design. By completely separating the what from the how, you allow different parts of the system to share a common understanding of reality without forcing them to share behaviors.
Right.
The types module becomes the single source of truth. Once that shared reality is established, the rest of the application can just independently figure out what to do with it.
And armed with this new philosophy of separating data from logic, Aang's perspective shifts entirely. It's like putting on a pair of X-ray glasses and suddenly seeing the matrix of the code.
Yeah, totally.
The developer log concludes with Aang looking at another part of the project entirely, a module called xs2ebook.parser. Right, a parser. And a parser takes messy raw input from the outside world and structures it so the rest of the program can actually understand and use it.
Yeah.
It's an inherently complex piece of logic.
And Aang notes in the log that this parser module is really starting to grow. It is becoming a very messy kitchen counter.
But now, having just learned the immense value of extracting types into neutral modules, Aang has a proactive strategy.
Okay.
Aang plans to apply this exact same refactoring concept to the parser module to tame its complexity as the project moves forward.
It's so interesting how a simple bug that just ruins your morning ends up handing you the exact blueprint you need to fix the rest of the project.
Oh, absolutely.
You start your day with a frustrating circular dependency, you dig into it, and you end up uncovering a fundamental architectural truth. The value of the bug is that it gives you the exact lens you need to prevent future messes.
It really marks the transition from reactive programming, just putting out fires as they pop up, to proactive architecture. You are basically looking at the walls of the house and deciding to separate the plumbing from the electrical wiring before the drywall even goes up. You're changing the environment so the gridlock cannot happen in the first place.
We've covered some really fascinating ground today. Let's do a really quick recap of the journey we took.
Sure.
We started with a project-halting circular dependency in Aang's Xto ebook project. The converter needed the CLI, and the CLI needed the converter, a complete compiler gridlock caused by the temptation of convenience.
Yeah. And from there, we move through the tactical solution, right? Extracting the data and its fundamental identity properties into a neutral xtest2ebook types module.
Exactly.
This established a strict one-way flow of dependencies, serving as this bedrock layer that finally broke the gridlock.
And ultimately, we arrived at a truly universal principle: the profound importance of separating the definitions, what the data actually is, from the logic, how that data is handled and manipulated.
Right.
While this deep dive was rooted in a highly specific Haskell programming issue, this core insight is universally applicable.
It transcends code entirely, honestly. It's about how we structure reality.
Whether you are managing a large corporate team or organizing a massive research project or even just building a personal workflow, clearly defining what your materials are separately from how you use them, that is what prevents systemic gridlock. You have to keep your pantry separate from your stove.
It's the only thing that allows for clarity, independence, and real scalability in any complex system you interact with.
Which leaves us with a final provocative thought for you to mull over and explore on your own. We've seen how separating what things are from how we use them solves systemic loops in software architecture.
Yeah.
Where else in your daily workflows or even in your own decision-making processes are you tangling your definitions with your logic, creating your own real-world circular dependencies? Where are your keys locked in the car, just waiting for you to step back and separate the what from the how?